Okay, we're just gonna have a short little video here. In the last video with the tensor operations, I was working with using a tensor for the first, tensor for the output, tensor for the first input, and a matrix for the second input. That's what I showed in the last video. And it would be basically this matrix here would be the weights portion once we get into the neural network part of the videos series. But I ended up deciding I don't want this. So all of that basically gonna go like that. You can keep it. It's not gonna make any difference as long as you yeah, it won't make any difference. You'll be throwing tensors in. So real quick, I'm just going through what this one's going to be like. It's not going to be a huge difference, obviously, but you can throw your asserts in here. Make sure the dimensions all match up where they should between A and B, and destination versus the correct side of B, destination versus the correct side of A, just like it would with matrices. But yeah. And then I made variables for the depth, the rows, the destination columns, which is the, so we'd have depth, rows, and columns for the destination, which is our output, which is equal to depth is batch size, rows would be the sequence length. If you're doing a decoder transformer, autoregressive transformer, and then DST calls would be the output shape, the number of neurons kind of thing. Yeah. And then T calls is the A-shaped dimensions 2, which is the columns of the input tensor, you could say. That's the one that gets reduced. This is the dimension that gets reduced in the matrix multiplication. And then we're just going to do a for loop through each of these, through the depth, through the rows, destination columns. These three for loops are going to each have their own, what am I saying? Each one of these for loops is going to point to a certain location of the output, aka the destination, DST. And then you do a sum, which you go through the T calls and you accumulate the sum, and reduce those down, that dimension down. A dot data I times rows times calls plus J times calls plus L times B data I times T calls times DST calls. And this mapping, you can just go back to matrix version. It's the same except for an extra dimension added in there. You go across A and you go down B. So across A to accumulate, multiplying with going down the columns of B. And then Once you have the sum, you throw the sum into the dst.data. And maybe later on I'll do a batch matrix multiply, adding in the bias. But this is all I needed to show you right now for the next video, which is setting up a dense neural network, dense layer for proceeding into the transformer, further into the transformer series. So that's all.